Kaku has also weighed in on the role of transparency in resolving the debate. He agrees with Loeb on one important point. More data should be made available. NASA reportedly captured high-resolution images of 3I/Atlas on October 2nd, but these images have not yet been released to the broader scientific community. Kaku believes that sharing this data would allow researchers worldwide to conduct independent analyses, helping to clarify the object's true nature. Despite his openness to further investigation, Kaku remains firmly convinced that 3I/Atlas poses no threat and represents no evidence of extraterrestrial technology. NASA has echoed this assessment, stating that the object will pass safely through the solar system and poses no danger to Earth. 3I/Atlas is expected to make its closest approach to our planet around December 19th before continuing on its interstellar trajectory, eventually leaving the solar system behind. Beyond the specifics of this single object, the debate surrounding 3I/Atlas highlights a deeper tension within modern science communication. On one hand, bold ideas and speculative thinking can inspire curiosity and drive exploration. On the other, unchecked speculation can generate unnecessary fear or confusion, especially when amplified by headlines and social media. When asked what he might say directly to Loeb regarding his more sensational conjectures, Kaku offered a measured response. "Speculation is fine," he said, "but you have to quantify it." In other words, scientists must clearly communicate the level of confidence behind their ideas. Is a hypothesis supported by strong evidence, or is it merely a remote possibility? Without that context, the public may struggle to distinguish between established science and imaginative extrapolation. This emphasis on probability and evidence is central to how science progresses. Most anomalies, history shows, eventually find explanations within existing physical laws once enough data is gathered. From pulsars initially being dubbed little green men, signals to the early mysteries of quasars. Cosmic history is filled with phenomena that seemed inexplicable at first but later became well understood. 3I/Atlas may well join that list. As one of the few confirmed interstellar objects ever observed passing through our solar system, it offers a rare opportunity to study material formed around another star. Its age, composition, and trajectory could provide valuable clues about conditions in distant regions of the galaxy long before Earth even existed. Rather than seeing it as evidence of alien technology, Kaku encourages the public to appreciate 3I/Atlas for what it most likely is, a natural relic of the early universe, carrying within it a chemical record of cosmic environments humans can never visit. In that sense, the object is no less wondrous for being natural. A 7-billion-year-old traveler from another star system is, by any measure, extraordinary. As scientists await the release of additional data and continue to refine their models, the story of 3I/Atlas serves as a reminder of both the vastness of the cosmos and the importance of scientific restraint. Curiosity must always be paired with rigor and imagination with evidence. Only then can humanity truly understand the messages carried by visitors from the deep, silent reaches of interstellar space. In recent weeks, an interstellar visitor known as 3I/Atlas has captured global attention, igniting debate across scientific circles and the public alike. Its unusual characteristics, most notably the absence of a traditional cometary tail and the detection of unexpected nickel emissions, have prompted some to speculate about extraordinary origins. While a small number of voices have raised provocative ideas suggesting artificial or even extraterrestrial explanations, prominent physicists urge a far more grounded interpretation. Among them is Michio Kaku, who argues that the object's mysteries are best explained not by alien engineering, but by immense age and cosmic history. Kaku, a theoretical physicist and best-selling author known for works such as Hyperspace and Quantum Supremacy, addressed the topic during an appearance on NewsNation Prime. His central claim was clear. 3I/Atlas is unusual because it is ancient, possibly far older than any comet previously studied by humanity. According to Kaku, this vast age alone can account for many of the anomalies that have fueled speculation. To understand why 3I/Atlas has drawn such scrutiny, it is important to first understand how comets typically behave. Most comets observed within our solar system originate from regions like the Kuiper Belt or the Oort cloud. These objects are generally between 3 and 4 billion years old, forming during the early stages of planetary development. As they approach the Sun, solar radiation heats their icy surfaces, causing gases and dust to vaporize and stream outward, forming the iconic glowing tail that has defined comets in human imagination for centuries. 3I/Atlas, however, defies this familiar pattern. Despite passing relatively close to the Sun, it exhibits little to no visible tail. Instead, spectroscopic analysis has revealed something far more puzzling: strong emissions of nickel. Nickel is not unheard of in space, but its prominence in the emissions of an object that lacks the usual dust and gas behavior of a comet is highly unusual. These findings were among the observations highlighted by Avi Loeb, a Harvard professor who has become well known for entertaining bold hypotheses about interstellar objects. Loeb has previously argued that certain unexplained space phenomena, such as the interstellar object Oumuamua, could potentially be artificial in origin. With 3I/Atlas, he has again pointed to irregularities, including its composition and apparent changes in velocity, as reasons to consider unconventional explanations. In one widely circulated remark, he suggested the possibility that the object might be revving an engine, a phrase that quickly captured media attention and public imagination. Kaku, however, takes a much more conservative view. He emphasizes that science advances not through sensational speculation, but through careful analysis and probability-based reasoning. According to him, the most striking feature of 3I/Atlas is not that it behaves like a machine, but that it behaves like something unimaginably old. This is a very old object, perhaps 7 billion years old, Kaku explained. If correct, that would mean 3I/Atlas predates our solar system itself. Over such an immense span of time, the object would have traveled through multiple stellar neighborhoods, exposed to different radiation environments, shock waves from supernovae, and a wide variety of interstellar gases and dust clouds. This long journey, Kaku argues, provides a straightforward explanation for the comet's unusual chemistry. Nickel emissions, while rare in younger comets, could result from prolonged exposure to extreme conditions over billions of years. As the object passed through diverse cosmic environments, it may have accumulated or altered its elemental composition in ways that modern astronomers rarely observe. In this context, the absence of a traditional tail also becomes less mysterious. A comet that has spent billions of years shedding volatile materials could be significantly depleted of the ices that normally produce dramatic outgassing when heated by the sun. What remains would be a more inert body, still technically a comet, but one that behaves very differently from its younger counterparts. Another point of contention has been the observation that 3I/Atlas appeared to increase its speed as it passed the sun. To some, this acceleration seemed difficult to explain without invoking artificial propulsion. Kaku strongly disagrees. He notes that there are numerous natural mechanisms that can alter an object's velocity in space. Uneven heating, asymmetric outgassing, or even the breakup of a fragment from the main body could all produce a sudden change in speed. There could be reasons that explain why there's a sudden spurt in velocity, Kaku said. That's not a smoking gun. This perspective reflects a broader principle in astrophysics. Extraordinary claims require extraordinary evidence. While it is tempting to interpret unfamiliar data as signs of advanced technology, doing so without robust proof risks misleading the public and undermining scientific credibility.